This is my third introduction for Laplace transform. I am putting inverse of transforms under this introduction. So there are a series of introductions I've done 1 and 2. The first one talks about intro to Laplace transform itself. Then I did intro to transform of derivative. I labeled that one part 2. And this is intro to Laplace transform part 3. I want to talk about inverse transforms. So here we want to find the reverse process of the transformation, okay? The reverse process of the Laplace transformation. So, for instance, given a Laplace transformation of, let's say, L of f of t. In the introduction, we learned that the Laplace transform of f of t is the same as f of s. If you watch Intro to Laplace transform, you will see this, okay? Now, the reverse of f of s should give us what? F of t. Okay, so L inverse of f of s should be equal to f of t. All right, very simple. Now let me take an example. Remember that in the video for finding the Laplace transform of an exponential function e to the power at, we learned that if the Laplace transform of the function e to the power at gave us the result 1 over s minus e. I guess you remember this. So if you have watched my video for Laplace transform of this function, we learned that this is the result. So once we take the inverse of this one, we are supposed to get back this. Let me give you an example. Now, for example, let's take the Laplace transform or Laplace transform of e to the power 2t. A here is equal to 2 because a is a scalar. Now, after proving this equation, this was the result. We learned that the Laplace transform of e to the power at was generating 1 over s minus a. Now, if a is 2, then let's substitute it there. The result we are getting is 1 over s minus 2. Okay, now this is your solution for this particular question. Remember that I'm just taking a shortcut method because we will be applying this. If I want back my e to the power 2t, then I'll just take the inverse of this one. And this will give us the Laplace inverse of the function 1 over s minus 2 should be equal to e raised to the power 2t. Again, the other videos, we also learned that the Laplace transform of sine at was generating a result after proving and solving. The result was giving us a over s squared plus a squared. For example, let's find the Laplace transform of sine 3t. Watch carefully. From the proving, Laplace transform of sine at will give you this result. So the Laplace transform of sine 3t will give you 3 over s squared plus 3 squared, giving you 3 over s squared plus 9. Very simple. Now, if I want to get back my sine 3t, then I have to find the Laplace inverse of what? This result. Hence, the Laplace inverse, L inverse of the result we have here, 3 over s squared plus 9, is going to give us L inverse of, we break it down, 3 over s squared plus 3 squared, which is equal to what? Sine 3t. Do we get it now? Again, you learned that the Laplace transform of cos at. Please, I have already discussed all these videos in the playlist Laplace Transformation Engineering Mastery. So you can locate this one, Laplace transform. If this is your first video, locate Laplace transform of cos at, sin at. You look through, I've arranged these videos in the playlist accordingly the way you will understand it. Okay, so this one, the result was giving us s over s squared plus a squared. Now, for example, the Laplace transform of cos 5t will generate this. Replace a with 5. Remember, once you solve this by proving, you get what? S over s squared plus 5 squared, giving you s over s squared plus 25. So all we are discussing here in inverse transform is that you just take the inverse of this side. If this is the question given to you, then the Laplace inverse of the function s over s squared plus 25 is the same as you saying the Laplace inverse of s squared plus 5 squared. Now, from here, you can say that this result is equal to cos 5t, because the Laplace transform of cos AT is equal to this. Let's talk about the fourth one. Now, previously, we studied that the Laplace transform of sin AT, which is a hyperbolic function, generated the result A all over S squared minus A squared. Now, let's take one example and use it, then we find the inverse. So watch this very carefully. The Laplace transform of sin AT will give you A over S squared minus A squared. This is our A. This is 4. 4 is multiplying this result. So we can write our 4 somewhere here and wait. Now this will multiply the result A, which is 3. So we have 3 over S squared minus 3 squared. What are we getting? This is giving us 4 times 3 over S squared minus 9. And we can simplify this by using this 4 to multiply this, giving us 12 over S squared minus 9. You can choose to leave the answer here or break it down to this form. Now watch this carefully. How then do we find the inverse of this? Now, it is very simple. We take the inverse of this one and convert it back here. So the Laplace inverse, L inverse of 12 over S squared minus 9. Break the numerator down, because you know that 3 squared will give you 9. So this will give us 4 times 3 over S squared minus what? 3 squared. And once you continue this, the result becomes 4, because you know this one is sin 3t. So 4 times sin 3t, giving you 4 sin 3t. As simple as that. Now, so the inverse of a Laplace transform is very simple, because we don't need to go through the whole process to prove the solution for this particular one. We don't need to prove it, because now we already know that the Laplace transform of this will generate this. We don't need to prove it again. So with this knowledge, we just go reverse. We just reverse the transformation, and then we arrive at the answer. So you look at the answer very well, the question given to you rather very well, to see if it is a cos function, a sine function, an exponential function, or a hyperbolic function. I will work on the last function, and then we end it here. Now, if you have watched my introduction for Laplace transform part 1, I discussed this one there. Finding the Laplace transform of a what? Let's say a scalar of the variable a. The result will give you a over what? S. So assuming a is any random number, the Laplace transform of the function, let's say 4, 3 or 2, will give you what? 4 over S. Do we understand? So from here, what if I now have 4 over S and I want to get back to this one? I'll just take the inverse of what? This 4 over S. So Laplace inverse of 4 over S is equal to what? 4. The Laplace inverse of minus 3 over S is equal to minus 3. So that is it. Very, very simple. So the inverse of a function is just the reverse of the transformation. Okay. We need this knowledge, because once you tackle Laplace transform of first order differential equation and second order differential equations, including partial fractions, you will be applying what we call the inverse of Laplace transformation. So that is why I'm talking about this one in this video. So any question I have tackled under transform of derivatives and partial fraction, finding the Laplace transform, we are going to apply inverse of the Laplace transform, and I will direct you back to this video. So let me end it here. This is Tutor Think. My name is Dan. You can call me Danjin. I prefer Danjin. All right. Please subscribe to this work. Support this work. Click on notification for more updates. And I'll see you in the next one.